We are continuing to combination, and we are continuing with the combination lesson 11 questions. In a queue of 5 students at a canteen, 2 students from class A and the rest from the class B. If it is known that there are 7 students in a class A and 9 students in class B, how many different ways are possible to form the queue? It says here. So first we are going to select 3 people and 2 people from different classes, and then we are going to form them. First, we are starting with the selection part. If there are 5 students and it says that from A and B, we are selecting 2 students from class A, 2 students from A, and 3 students from B, and we know that in A there are totally 7 students, and in B there are totally 9 students. So from 7 we are going to select 2 of them, and from 9 we are going to select only 3 of them. Here the selection part finished. Then this part is selection part. After this part we are going to arrange them. In how many different ways 5 persons can be arranged in the queue? We can form a queue with them. Okay, this is the 5 factorial. So to form a queue, okay, there are 9 students in a class. 4 of them will be chosen to go to picnic, and the rest of them form a basketball team. In how many ways? So we are going to select only 5 students here, because the rest of them already they are going to form a basketball team. So combination 9 with 5, 9 with 4, 9 with 4, because 4 of them they are going to go to picnic. Combination 9 with 4 it's going to be, and from 5 all of them already chosen for the basketball team. Actually there is no selection here. The answer is combination 9 with 4 is going to be. Okay, in this question a football team is made up 10 players plus goalkeeper. 5 more players are reserves. The team coach wants to substitute 2 team players, not including the goalkeeper, with 2 reserves, and then to choose 3 forward players from the resulting team. And if each player can play in any position, in how many ways can coach choose 3 forward players? In this question, firstly, we need to know this one. We are going to select 2 substitutes firstly. We are going to select 2 players, and we are going to substitute with them with the reserves. So from 10, we are going to select first 2, and we are going to substitute them with the reserves. And from 5 reserves, we are going to select 2, we are going to change with the players. Then we have now we made this substitution operation, and after the resulting team, from the resulting team, we are going to choose 3 forward players. And again, the forward players' places are not important, left, right, or middle. It is not written here, and that's why we are going to select again with the combination. From 10, we are going to select 3 forward players, and we are going to finish the operation. Okay. In canteen, 2 circular tables, 4 seats, and a bench with 5 seats. In how many ways 13 students can be chosen from 15 students? So if there are 15 students, first we are going to select 13 of them. There are 15 students, first we have select 15 of them. And the order is not important now, because first we are selecting them. Then, after that selection, we are going to select from 13, 4 of them for the circular table, and 4 of them for the, we are going to select 13, we are going to select from 9, 4 of them again for the circular table. Why 9? Because first you have 13, and when you select 4 of them for the circular table, we have 9 students left, And from 9 students, 4 of them again we are selecting, and that means you have left 5 students. From 5 students, 5 of them they are selected for the bench. That's why we are not selecting for the bench. Okay, now after this part we are going to start to seat them. In how many different way this 4 student can be seated around the circular table? This is going to be 4 minus 1 factorial. Okay, then second group of here 4 minus 1 factorial way they can sit around the second circular table. Okay, now there are 5, and these 5 people can sit around the circular table for 5 factorial different way, and this is going to be the answer of our question. Okay, this is the new type of question. Here, 13 bulbs in a box, 5 of them defective. There are 13 bulbs, 5 of them defective, and it means that 8 of them normal it's going to be. We will select the set of 4 bulbs from the box. In how many ways we can do this one? So bulbs are identical, the colors are not mentioned here, or they don't have different colors. That's why we are going to select with combination. And if it says none of the bulbs must be defective, we are going to select 4 bulbs, and none of the bulbs must be defective means from 5 we are going to select only 0, and from 8 we are going to select 4 of them. This is the answer of the first part, A. And here we have another question, B. We want at least half of the set to be defective. At least, when it says at least, if there are 4 bulbs, at least half means 2, 3, or 4 it should be. So for the B1, we are going to use again permutation, but we are going to select from both set, because if 2 of them defective, 2 of them it should be normal. So from 5, if I select 2 of them, at the same time I can select from 8 2 of them, and that is going to be totally 8. And selection of 2 defective bulb and selection of 3 defective bulb cannot happen together. That's why we are using addition here. And 8 with, you have selected 3, so rest of the group is going to be 8 with 1. And the last one is going to be here 5 with 4, 8 with 0. 8 with 0 and 5 with 0 I didn't write here, but they are going to be equal to n with 0. n with 0 is going to be equal to 1. So here this is going to be also equal to 1, and there is no need to write this one, or this is going to be also equal to 1, so there is no need to write this one. The answer only 8 with 4 we can say for the A choice, and this is the answer of the B1. Okay, and we have 11 points on a circle, and we are going to form a triangle. So it means that from 11 we are going to choose 3 of them, and the order is not important. Which vertex has chosen firstly, it is not important. That's why we can select with combination. From 11 we are going to select 3 of them, and the answer is going to be 11 with 3 only. Here again I want to mention in the triangle vertex selection, which vertex chosen firstly is not important. That's why we are writing like this. Okay, a box holds 7 red cards and 5 green cards. How many different groups of 6 cards can be chosen if the selection must contain at least 3 red cards? Again, we have at least 3 red. At least 3 red means 3 red or more, which means more means 4, 5, and 6 red cards. So there are 7 and 5 cards, 7 of them red, 5 green we have. So we are going to select from 7, 3, we are going to start with this one. If I select totally 6 cards, it means that from 5 also I'm going to select 3. This 2, it should be equal to 6 here, plus. Now I select 3 red cards. Now it says more. More means 4. 7 with 4 can be, and if I choose from 7, 4, from 5, I have to choose 2 only because totally 6 cards is going to be. Then 7 with 5 and 5 with 1. The last one is 7 with 6 and 5 with 0, but it is not written as I said to you because it's equal to 1. Already when you have 6 cards, you are already select all the cards. That's why you are not going to select from the green cards. We are going to form the parallelograms. To form the parallelogram, we are going to select 2 parallel lines. You know that one. From this group, we have to select 2 parallel lines, and we have to select 2 parallel lines to form the parallelogram. Okay. From D group, D1 to 4, I'm going to select 2 of them, as I said. Let's say I'm going to select this 2. Then from this 2, I'm going to select this 2. As you see, I form a parallelogram here. Okay. Then from 4, 2 of them you are going to select. From 7, 2 of them you are going to select. And which one is chosen firstly, it is not important. That's why you are going to select with combination.